Shortly before graduating, a group of young engineers are in a quiet, solemn room standing shoulder to shoulder. Each one of them is about to receive a small, unadorned ring worn not for fashion, but as a symbol of something far greater. This is the Iron Ring Ceremony, a uniquely Canadian tradition that has marked the transition from engineering student to professional for over a century now. The ring, worn on the little finger of the working hand, is a constant reminder. It taps against the desk, the keyboard, the blueprint, if people still use blueprints, that the work of that engineer carries weight, consequence, and duty. Born from a tragedy, the collapse of the Quebec Bridge in 1907, due to design flaws that sadly killed 76 people. The ceremony was brought to life by engineer H.E.T. Haltain and author Rudyard Kipling to instill a deep sense of ethical responsibility in those who build the world around us. The oath taken, known as the obligation of the engineer, is not legally binding, but it is morally profound. It calls for integrity, humility, and a commitment to public safety, values that transcend borders and discipline. Although some of my fellow engineers have told me they had found the tradition odd or eccentric, every single one of them highlights that responsibility of that promise stays with them forever. And while the iron ring is distinctly Canadian, it has inspired many similar traditions around the world, from the Order of the Engineer in the United States to the NTH ring in Norway, and even to proposed Hippocratic-style oaths for scientists. Today, as we explore the modernization of our industry, of engineering and science, let us keep top of mind what it means to wear such a ring, not just as a symbol, but as a promise. Take a moment to look around you. The roads we travel, the buildings we live and work in, the energy that powers our homes, the digital tools we use to connect or even make these broadcasts, even the restored wetlands and green spaces we enjoy, every single one of these was shaped in some way by the hands and minds of engineers and scientists. Their work is embedded in the very fabric of our daily lives, most of the time invisible, but essential. Today, we stand at a remarkable crossroads in our industry, a moment where the physical and virtual worlds are no longer separate spheres. They are becoming deeply intertwined. This convergence is not just a technological shift. It's a transformation in how we understand, design, and interact with the world around us. Just a few years ago, it would have been unthinkable to simulate the entire life cycle of a building, from the time it's designed through its lifespan all the way to demolition. Now, advanced digital twins allow us to do just that. We can optimize energy use, predict maintenance needs and costs of that building, reduce its environmental impact, all before a single brick is laid. These advances are not just impressive, they are redefining what it means to be an engineer or a scientist. We are no longer just builders of the physical world. We are stewards of complex, interconnected systems that now span both atoms and algorithms. And with this power comes a renewed responsibility to that promise, to ensure that those decisions lead to real-world outcomes that are valuable, but also ethical, inclusive, and sustainable. This new frontier where innovation and imagination meets precision, not probabilities, precision, and where the future of our built and natural environments is being shaped in both code and concrete. Now imagine with me a future where every engineer is partnered with a dedicated virtual engineer. I am not speaking of a chatbot or a tool, a true thinking partner. This virtual colleague can dive into the deepest layers of geotechnical data, scan decades of environmental modeling, and explore thousands of design options in the time it takes us to take a single breath. It carries the knowledge of legions of engineers and scientists who have gone before. Suddenly, the impossible becomes routine. A bridge designer in New Zealand can now instantly learn from a risk model developed last week by another engineer in Toronto. Decisions that once took days of back and forth can now happen before you have lunch today. And because the human engineer stays firmly in the driver's seat, every choice is grounded in human judgment, ethics, and care for the communities they serve. Think about the potential benefits we unlock when engineering, science, technology, and AI are all part of a single living system we can see, sense, and shape in real time. Picture a twin of an entire city, your city. Not a static model, but a learning dynamic reflection of the world outside your window. A platform that tracks thousands of variables at once. Satellite imagery, air quality shifting street by street, water moving through a watershed, traffic patterns as they ebb and flow in and out of the cities across the day, energy demand rising and falling around the rhythm of our personal daily lives. And this system doesn't just report what's happening, but it uses real domain expertise and insight to predict what will happen next, help us prevent problems we used to spend time reacting to or suffering from, or uncover opportunities that bring value to clients and communities. This is no longer the domain of science fiction. These two examples I just gave are being made real by some of the smartest engineers, scientists, and technologies that I have the privilege of working with every day. When I started my career as a robotics and automation engineer, I was inspired by a curiosity of how things worked. And I wanted to combine mechanics with code to build machines that did things that seemed impossible. And while I have to admit my team and I at university never got that single-legged hopping robot to be dynamically stable, by the way, that's child's play today in modern robotics, the lessons I learned have stuck with me for decades. Today, modern robots can do things that would have been nearly miraculous 5 years ago. So as we look ahead in a time when digital and AI transformations unfortunately arrive wrapped in more hype than hardware, anchoring our work in a shared promise to serve humanity isn't about resisting progress. It's the steady, enduring wisdom that keeps us improving the world in ways that outlast the headlines. What gives me confidence that we will avoid modern versions of the Quebec Bridge tragedy of 1907 is not the advancement of technology and innovation and AI. It is the character of the people shaping it. People who innovate with purpose, decency, and a professional duty. Let us expand that promise of the engineer to ensure that our work benefits humanity and protects the well-being of all life on this planet. Why not expand that promise to all professions? Not to slow progress, but to guide it and amplify it. Because progress at the end of the day isn't just about the cool innovation, the cool tech, nor is it just about what we build. It is about the impact that we create on people, communities, and this planet. Thank you for taking the time to listen to me today.